Today we will solve the problem 4.29 of Griffith third edition Introduction to Quantum Mechanics, chapter 4. The problem 4.29 consists of two parts. First we will see the part A. Check the spin matrices equations 4.145 and 4.147. The equation 4.145 is that is S Z sub Z, this matrix, Pauli spin matrix, and 4.147 is these two, that is Pauli XY matrix, these two. So this is 4.15, 145, other two are 4.127. Obey the fundamental commutation relation for angular momentum, that is equation 4.12134, this one. We got to prove this. So first take this one. That is the commutation between Sx and Sy. I have taken this. This can be written as by definition Sx sub x Sy minus Sy Sx. So X matrix is H cross by 2 and Y matrix also H cross by 2. Of course, this is 0, 1, 1, 0. This is 0 minus I and I is 0. So I have taken this is Sx. This matrix is Sx. This is Sy. Here this is Sy and this is Sx. Now we will reduce this one. So we got this relation. Now you this H cross squared over 4 we got because Sx matrix contain H cross over 2 and Sy also H cross over 2. So if you multiply you will get H cross squared over 4. Now this is a Sx matrix Sy. Now you multiply this. First row, first column, you will get I. First row, second column, you will get 0 because 0 I 0, 1 0 0. Similarly, second row, first column. Here you will 1 0 0 0 I 0. And second row, second column, this one. Second row, second column. That is second row is 1 0. Second column is minus I 0. So you will get minus I. You do the same thing for this matrix product. You will get uh, first row, first column, you will get minus I. First row, second column 0. Second row, first column 0. Second row, second column is I. Now you can notice this is negative sign. So if you subtract both the matrix, you will get here minus of minus I is equal to plus I, that is plus 2I. Similarly, here you have minus I of minus I is minus 2I. Now you take minus 2I outside. Here you can take minus 2I outside. So this matrix become, you take 2I outside, just 2I outside. Then it will become 1, 0, 0, minus 1. This is minus 1. Now here this 4 and 2 will get cancelled. You will get 2 in the denominator and of course you have one I. So you can take I h cross squared. I am rewriting this I h cross squared as I h cross into h cross. Of course, you have already 1 over 2. I am taking that also. So I h cross squared over 2. So now what is this matrix? H cross divided by 2 into this matrix 1 0 0 minus 1 is Z matrix. So this commutation relation is Sx with the commutation of Sx with Sy is equal to I H cross Sz. That is first one. Adopting the similar way, you can prove other two also. That is, commutation of Sy Hz will give you I H cross Sx. Similarly, Hz with Sx gives you I H cross Sy. So you can prove all the three in a easy manner. Then we will move on to next part. Uh, Next part is so that the Pauli spin matrices satisfy the product rule sigma j into sigma k is equal to delta jk plus I summation over L epsilon jkl sigma L, where the indices stands for x, y, or z, and epsilon jkl is a well-known Levi-Civita symbol. So this is equal to 0 if any two parameters are any two indices are same. If it is plus 1, it is in cyclic order. Otherwise, it is minus 1. So here you can carefully note that either this will be 0 or this will be 0. Both are mutually exclusive. When this delta function is 1, then this will be 0. If delta function is 0, this will be 1. See, j and k are 1, same, then this will be 1. However, this will be 0. If j and k are different, this will be 0, this will be 1. So, both are mutually exclusive. That you have to keep in your mind. So, these are the three Pauli matrices. Yeah, see, remember earlier we used the Sx, S sub x, S sub y, S sub z. In that case, H cross over 2 will become uh, the multiplicative factor of this matrix is H cross over 2. In order to have a mathematical advantage, we assumed H cross over 2 is 1, and we labeled this Sx by sigma x, Sy by sigma y, Sz by sigma z. Because we assumed H cross over 2 is 1. Then you multiply this matrix and this matrix. Sigma x and the matrix sigma x itself. So both are same, only the first term exists. So if you multiply this, you will get 1001. This is a simple multiplication. Then similarly, sigma y. The first term is 1 because both are same. Multiply this 0 I 0 0 minus I into 0 plus I. So I into minus I into I is minus I squared, which is 1. So same is the case for second row and this one. So this will also become 1001. It's a simple and straightforward multiplication. So sigma z into sigma z, that also will become 1001. That is all the product are unit matrix. That is sigma x squared, which is equal to sigma y squared, which is equal to sigma z squared. In general, we can write this as sigma I squared, which is equal to unit matrix. We have solved when both the symbols are equal. Then what will happen if it is different assertion? The first term will become 0. This only exists. Now the j and k are different. So naturally, the first term is 0. Only the second one exists. So you multiply sigma x sigma y. Earlier case we have considered sigma x. So first term exists, second one will be 0. Here x y. So this is sigma x matrix. This is sigma y matrix. You multiply 0 1 0 I, so you will get I. Similarly 0 1 I 0, you will get 0. Same thing, if you multiply second row first column 0, second row second column minus I. And now you take I outside. Then you will get the first term will become, this is 1, this is minus 1. So what is this matrix? This matrix is sigma set. Of course, we have I in front of it. So I is sigma z. Same thing, if you multiply sigma y and sigma z, this is sigma y matrix and this one is sigma z matrix. If you multiply this, you will get 0 I 0. So if you take I, you will get 0 1 1 0, which is equal to I. This matrix is sigma x matrix. Sigma x. Of course, you have I outside. So same thing, if you multiply sigma z and sigma x, this is sigma z matrix and this is sigma x matrix. Then you will get 0, 1, minus 1, 0, which is equal to, you take I outside. Here there is no I, but I into I is minus I is equal to minus I squared, which is equal to plus 1. Same thing, I into I is equal to I squared, which is minus 1. I have rewritten this. I have taken out 0 minus I 0. This is sigma y matrix. Sigma y matrix. Of course, you have I here. Same thing, if you reverse this order, instead of xy cyclic, anti-cyclic, yx, then you will get negative sign. Same result with a negative sign. Sigma z, sigma y is equal to minus I sigma x. Similarly, sigma x, sigma z, because it's not zx, xz. So naturally, you will get one negative sign, minus I sigma y. So this is the unified relation. This relation is unified. It's valid when ij is equal to 1 or not equal to, sorry, if jk are equal or j and k are not equal. So this is unified expression. Thank you very much for watching my video and supporting me continuously. Thank you very much.